Hi, I'm Rob Shore, Director of Product Marketing for Coriant. In this video, what I want to take a look at is an interesting change that's happening in the telecommunications industry. Now, this is a change with a pretty broad-reaching implications, but we're going to focus very specifically on how this is impacting the transport networks. And this is a change that I call the data center effect. But before we look at the data center effect and how that's impacting transport networks today, I want to take a look at how the network used to be. Then we can see how this change is impacting things. So if we look at traditional transport network, you've got metros and long hauls, and you have these application providers that want to provide these services to different customers. And the way these application providers have traditionally worked is they would build these very large, nationalized, these centralized data centers where they would put all their resources and then run those applications from those resources in those data centers. Then when customers wanted access to those resources, in those applications, they would connect through their service provider, who would connect them across this long-haul network and into those data centers. Now, the reason why the network was designed this way was because the resources inside those data centers were traditionally very, very expensive. So these application providers, they would want to minimize their investment in those resources and centralize them to enable them to support as many customers as they possibly could with as few resources as possible from as central of a location as possible. Now, this architecture caused a number of impacts in the industry. The first of which is, again, because these resources are very expensive, it really minimized the number of applications that were available to users, right? A person who wanted to launch a new application would require a pretty tremendous amount of startup capital to get that application going. So only the really big players were able to launch applications. On top of that, because the connectivity here to provide those services across these long-haul networks was very expensive, even the people that could afford to launch applications, they really had to minimize the amount of bandwidth in their applications. So it really reduced the kind of features they could provide and the quality of the services they could provide. So that's two implications it had. It also had another pretty interesting application that's pretty profound. Because if you look at these enterprise customers, like Coriant, for example, right? We're an enterprise customer. We also run a variety of different applications, right? Our mail server, file server, SharePoint. And the applications that we run, they run on the exact same type of resources that exist in those data centers. But because those resources were expensive and the connectivity to and from those resources was expensive, what that did is it forced us to build our own data center. And in fact, in our corporate headquarters right here in Chicago, we have a data center right there on the third floor with servers and storage devices just like in the data center. Right? And on top of that, we're running all our applications from there, but we also have all these remote locations that also need connectivity to that data center. So service providers created another service type that's called a virtual private network, a VPN, to enable us to get access from remote locations to our local data center without having to go through the public internet to give us better performance and more security. So this is the way the network used to work, right? We had an infrastructure that had fewer applications, lower bandwidth applications, and where enterprise companies had to build their own local data centers. So this is how it used to be. What's changed? Well, what's changed is that these resources, these primary resources inside the data centers, the servers, the storage devices, they haven't just come down in price, they've come way down in price, right? Dramatically reduced the price, and not just the price of the equipment itself, also the amount of power required, the space, the cooling, and essentially these resources have just become dramatically more accessible to a much wider variety of people. So what that's done to the network is these application providers that used to operate in these very centralized data centers, they've been able to take those resources and distribute them much, much more widely. In many cases, directly into the metro where their end customers reside. So when these customers now want access to those resources, yes, they still connect through their service provider, but that service provider can now provide them access to those resources without having to go through this long-haul network, right here in the metro. So what are the impacts now? We've got cheap storage, cheap processing, and cheap connectivity costs. What is the impact that that's had in the industry? Well, the first impact is these traditional application providers, they now have much more access to resources, much lower cost bandwidth. They are able to provide much higher bandwidth services, more services, higher bandwidth services, and to more customers. So that's the first impact. But on top of that, because these resources now are so readily available, virtually anybody who wants to can easily launch their own applications, right? It no longer requires all that upfront capital to launch a new service. They can just lease those resources from within these relatively local data centers. So we've seen just a plethora of new applications spring up, and all kinds of applications, not just competition to the traditional applications, but all kinds of new and interesting applications that are not only causing more bandwidth, of course, but they're also creating new connectivity patterns. So you can imagine the very first, most obvious implication that this has, right? More applications, higher bandwidth applications, is more bandwidth, right? It's causing more bandwidth in the network. So that's the most straightforward implication. But there's another more subtle but equally significant implication. Because, again, these applications are doing things more than just providing traditional types of services, and we can look at a good example of this, right? A good example of the new types of connectivity patterns that we're seeing from this application here. This is an application called Mint.com. I'm actually a Mint.com customer. What Mint.com does, it's a financial management application. It sits in the cloud, so it runs in a data center, and it manages all of my finances. So it actually connects to all of my other financial institutions, my bank account, my checking account, credit card account, and it actually aggregates all of the transactions from those different accounts and organizes them and enables me to create a budget. So yeah, that's great for me, but what does it do to actual traffic flow in the network? So yes, I have a connection from me to Mint.com, right? User to data center. They call that north-south traffic. But also Mint.com, what it does is it has to go to all those other applications where my finances are stored and gather that information. And most of those applications are probably running in other data centers. So we now end up with this data center to data center connectivity traffic pattern, right? This is a completely new type of traffic pattern that both service providers have to deal with, and transport network solutions should be able to effectively accommodate. So this is just the traditional applications. There's another, perhaps even more profound impact that this is having on the industry, and it's just starting to catch on now, but I think it's going to continue to grow over time pretty significantly, and it's going to have a dramatic impact on traffic in the network, and that's these data centers, right? These enterprise-built data centers. If you remember, why did Coriant build our own data center in our corporate headquarters? We built it because those resources in that centralized data center and the connectivity to and from it, it was too expensive. Well, in this new environment, that's not a problem anymore. Those resources are cheap, and connectivity to and from those resources is cheap. So what it's enabling us to do is take a lot of the applications we run in our local data center and offload them into the cloud. And over time, it should enable us to completely divest ourselves of those data center resources. Now, this is great for companies like Coriant because it enables us to focus on our core business. Our business is not running data centers. It's providing telecommunications solutions. And now we won't have to, by leasing these resources, we won't have to worry about buying servers, leasing servers, sizing servers and storage devices, maintaining and upgrading. We don't have to worry about that stuff anymore because we can just pay somebody to do that and lease exactly as much bandwidth, exactly as much server capacity, storage capacity as we need at any time. So again, that's great for Coriant, right? Helps us focus on our core business. But what does that do now to these transport networks? Well, if you think about it, inside, when we had our data center, inside our corporate headquarters, a huge amount of traffic as part of our day-to-day business, it actually stayed right inside our own building. It never left the building. But now that we're moving those resources and applications into the cloud, all of that traffic that used to be internal traffic, that now becomes external traffic and is going to hit this transport network. And this isn't just a moderate amount of bandwidth. It's not streaming a YouTube video. This is all our core business functions. This is going to dramatically increase the amount of bandwidth that's hitting these transport networks now. Okay? So this is the idea, right? This is the way things have changed. We've got more applications, more bandwidth, new connectivity patterns, and new types of services that are being offered in these networks. So let's take a look at some of the actual numbers behind these impacts and what this is doing to the industry. Well, the first and most interesting thing is this as-a-service market. This is an entirely new industry that really is just a handful of years ago never existed. These are the people that operate in and around the data center. So it's everybody from the people that own the building itself, to people buying servers in the data center, just leasing server space, to even some just infrastructure providers. So a good example of that is is SharePoint 365, right? A Microsoft service. We used to run a local copy of SharePoint on our servers in our data center. Now what we do is we lease this service from Microsoft, the SharePoint 365, and what that enables us to do is use that application, and we don't even need to buy servers or storage. Microsoft takes care of all of that. We're just leasing the service from them, completely getting us out of that business of having to worry about data center resources. So this is an industry that just recently came into existence, and it's growing extremely quickly. It's growing at about 25% CAGR, 25% year-over-year growth. So this is one impact, right, this brand new industry. But let's see what this has done to traffic. So data center traffic is just absolutely exploding. This is a traffic that's growing at 78% CAGR, just this massive growth, 78% year-over-year. And this is the impact of all of these services that are now new into the network that are being provided. So, but you have to be a little bit careful, right? When you look at the 78% number, right, you have to remember that that number also includes intra-data center traffic, right? 76% of the traffic is inside the data centers from the servers to the storage devices inside the data center. But that still leaves a full 24% of this volume that's growing at 78%. That's extra data center, right? North-south, so me to the data center and data center to data center. So we've got this traffic growing as a result of this phenomenon at a pretty substantial rate. So now there's one other really interesting thing. Yes, data is growing, traffic is growing, but remember this data centers are now inside the metro, and when service providers want to provide access to that, they can do that now without having to go through this long-haul network anymore. So that yes, while data is growing at pretty substantial rates, a huge amount of that growth is actually inside the metro. So yeah, long-haul networks are still growing at a pretty reasonable 12% year-over-year. But metro traffic is growing at almost double that, at 22% year-over-year. Right? So these are the impacts, right? Just massive growth in bandwidth and much more diverse traffic pattern, and really the growth focused on the metro. So what's the takeaway from all this? The takeaway is that we really need new types of transport networks. Traditional transport networks had a pretty straightforward problem to deal with. Traffic was reasonably uniform from the edge to the core, from the core to the edge, and it was really just about bandwidth, just coming up with enough bandwidth to provide these services. But what we're seeing now as these data centers are moving into the metros, as these applications are spreading out, as people are moving more of their information into the cloud and companies are actually offloading their own internal data centers into the cloud, what we're seeing is this dramatically more diverse set of traffic patterns. More people needing to connect to more locations, more sporadic connections, larger connections, even connections between applications themselves. So really the idea here is when we're building transport networks, we really need to understand these traffic patterns and what these networks now need to be able to accomplish. And it's not enough to have just a high bandwidth solution. We need a both solution that's flexible, where I can provision it flexibly and create flexible connectivity efficiently, but we also need adaptable solutions, right? Solutions that I can not only set up my connections, but I can move them around very easily and very flexibly and very efficiently without a lot of effort. So that comes to the end of our session here. Hopefully this data center effect, it makes sense and the impacts this is having to the network and what we need to think about as we're building new transport networks. If you want more information on any of Coriant's products or solutions, please visit us at Coriant.com. Hope you enjoyed this session, and thank you for watching.